Good morning, everyone. Thank you for joining us today. I'm Akshay Verma, alongside my teammate Royal Fish, and we're excited to present our capstone project, Medical Cost Prediction with Regularization. This project, conducted at the University of Petroleum and Energy Studies, leverages machine learning to predict medical insurance costs with real-world impact. Let's dive in. Okay. Medical insurance costs vary widely due to factors like age, BMI, smoking habits, and region, posing challenges for fair pricing and healthcare planning. Our goal to build a machine learning model that accurately predicts these costs using Ridge and Lasso regularization to prevent overfitting and ensure robust predictions. Why does this matter? Accurate predictions help insurance companies optimize premium, provide transparency for policyholders, and enable healthcare systems to identify cost driving factors. Our innovation lies in combining Ridge and Lasso regularization to balance model complexity and feature selection. As shown here, we start with data, build models, generate predictions, and apply them to real world use cases. Let's look at our objectives. Okay. Our project had four clear objectives. Predict medical insurances charges using regression models, apply Ridge and Lasso regularization to enhance model performance, evaluate models using R² and mean squared error MSE metrics, identify the key features driving medical costs. These goals guided our approach, ensuring both technical rigor and practical relevance. Now let's explore the dataset we used. So this is the dataset overview. We use the medical cost personal data set from Kaggle containing 1,338 rows and 7 columns. The features include numeric variables like age, BMI, and number of children, categorical variables like sex, smoking status, and region. The target variable, medical charges. The dataset had no missing values, but we needed to pre-process it. Categorical features required encoding, and numerical features needed scaling for model capability, compatibility. As you can see, we applied one hot encoder for categorical variables and standard scaler for numeric, ensuring our data was model ready. Let's talk about how we pre-process this data. Data pre-processing. Pre-processing was critical to our success. We used a ColumnTransformer pipeline to apply one hot encoding to categorical columns, sex, smoker, and region, and standard scalar to numeric columns like age, BMI, and children. This streamlined approach ensured our data was properly formatted for Ridge and Lasso regression. With clean data, we moved on to building our models. Model building. Ridge.
After data pre-processing, we implemented two regularization-based model. First is ridge regression uses L2 regularization with an alpha of 1.0 to shrink coefficients and reduce overfitting. Lasso regression uses L1 regularization with an alpha of 0.1, which not only prevents overfitting but also performs feature selection by setting some coefficients to 0. We selected alpha values through trial and error to balance bias and variance, and we used an 80-20 train split to evaluate performance. Now, here are the key results. Ridge regression achieved an R square of 0.7833 and an MSE of approximately 33.6 million. Lasso regression slightly outperformed it with an R square of 0.7836 and an MSE of 33.59 million. Both models explain about 78% of the variance in medical changes, with Lasso edge coming from its ability to select the most relevant features. We visualized these results with scatter plots comparing actual versus predicted charges, confirming the model's predictive power. Let's dive into what these results tell us. Now here are the key findings. Our analysis is revealed several insights. Both Ridge and Lasso models performed similarly, with Lasso slightly outperforming due to better feature selection. Smoking status emerged as the strongest predictor of medical costs, followed by age and BMI. Regularization effectively mitigated overfitting, ensuring our models generalize well to new data. These charts highlight smoking status as the dominant factor, which align with real-world healthcare trends. Now here are the challenges and solution. We faced three main challenges: categorical features encoding sex, smoker, and region for model compatibility. Solution: we used one hot encoder with a column transformer for efficient encoding. Hyperparameter tuning, finding well optimal alpha values for Ridge and Lasso. Solution: we tested values like 0.1, 1.0, and 10.0, setting an alpha of 1.0 for Ridge and 0.1 for Lasso. Data imbalance: smokers minority class could skew prediction. Solution: we used a robust string split with plans for oversampling in future work. These solutions kept our project on track and delivered strong results. Now, at last, I would conclude our Rich and Lasso models accurately predict medical insurance cost with an R square of approximately 0.78. Regularization ensured robust generalizability, and we identified smoking age and BMI as key cost drivers.
To enhance this project, we plan to test advanced algorithms like ElasticNet or gradient boosting for better accuracy. Engineer new features such as interaction terms like age smoker. Use GridSearchCV for systematic hyperparameter tuning. Incorporate larger datasets with additional factors like commodities. Implement five-fold cross-validation for greater robustness. These steps will further refine our model and broaden their applicability. Let's conclude. Thank you for your attention. We're proud of our work on predicting medical costs and excited about its potential impact.